Welcome back. This is the last lesson recording for IM2, November 12, 2020. So now we are up to card number 18 of Desmos. So we were finding the angle number 2 now. Angle number 2. Write the equation similar to Moran's to relate the angles and sides of this triangle. Okay, so we know this is the unknown angle that we do not know anything about, or the angle measure that we're trying to find. What is this side reference to the in relation to the reference angle? This is opposite side, right? So this is opposite because it's across from the angle, reference angle. And this is right next to, this side is right next to the reference angle. So this is my adjacent. So which is the trig ratio that deals with opposite and adjacent? That's tangent. So we know that tangent of some angle, so we're going to put question mark here. And I could use theta instead, but for now, since it's labeled as question mark, I'm going to do this. All right, so it's opposite over adjacent. So opposite is 3 and adjacent is 5. Okay, so, and 3 over 5, that's same as 0.6. Okay, now I need to be looking at my trig table to find what is the angle that's going to give tangent of the angle measured to be 0.6. If I go over here, okay, tangent is the very last column. So I'm looking for 0.6 along, okay, and 0.6009 is right here. What is the angle? That's very close, 0.6 angle, that's 31 degrees. So I know that the missing angle measure is 31 degrees. Okay, so I can write it there as well. All right, so then let's move on to the next card. All right, the different problem, write the equation that relates the angle and the side of the triangle. First, you need to identify the angles and not the angles, the sides and the hypotenuse. Okay, so this is my reference angle. In this triangle, what is 37? 37 is across from the right angle, so this is my hypotenuse. And the 29 is the leg next to the reference angle, so that's going to be adjacent. Okay, so adjacent and hypotenuse. So what is the trig ratio that deals with adjacent and hypotenuse? That's cosine. So cosine of question mark is going to be equal to, and cosine is always adjacent over hypotenuse, so that's going to be 29 over 37. Okay, so then cosine is, so then what is 29 over 37? If I use the calculator, 29 divided by 37 is 0.78, 0.7838 or 0.784. Okay, so then I need to look for 0.784 in my cosine. So I go to my cosine is the middle one, 0.784, 788 is here, 78, okay, so it's very close to 38 degrees. Okay, so it's 38 degrees would be my answer here. So the missing angle measure is 38 degrees. Okay. All right, then next, write the equation that relates the angle and sides of this triangle. Okay, this time you need to identify the sides. Again, this is across from the reference angle, so this is opposite. And this is right next to the adjacent, next to the reference angle, so this is my adjacent. So opposite and adjacent. Okay, so opposite and adjacent, so that means we're dealing with tangent of some question angle is going to be equal to opposite of adjacent, which is 9 over 32. And if I use the calculator, and 9 divided by 32 is equal to 0.28. 0.281. So again, I am looking for 0.281 for tangent ratio. So I go to 0.281. So 0.281 is going to be 0.281 is 262 0.26, 0.28. So that's very close to 0.281. So I'm going to say 16 degrees. So the missing angle measure is 16 degrees here. Okay, and we're done with the decimals. Okay, so I am going to introduce the notation for inverse trig function. Remember what we did when you looked up the trig table to find the angle. That's what we actually did was we did the inverse trig function. That means we undid the sine function to look for the angle measure. So this is the notation for what we exactly did, and I'm going to explain that more in detail. So for example, if you had sine of some ratio, sine of, so if you have sine theta is equal to x, and x being the ratio and theta being some degree, some angle measure, then this, the inverse function of this will be sine -1, and we read this as inverse of sine of x is equal to theta, where the x is the ratio number, okay, it's the ratio of the opposite divided by hypotenuse, and the theta is the angle measure. So in this case, the input in the inverse trig function is the ratio number, and the output, what pops out, is the angle measure. In contrast to the regular trig function, you are putting in the input is the angle measure and the output is the ratio, okay? And you read this as inverse sine of x equals to theta, or sine inverse of x equals the theta. So, all right, so that means the trig ratio and the inverses. Let's just do the comparison. Okay, so for sine, the notation for the trig ratio is sine of theta is equal to x. The inverse of sine is sine and it's -1. And this is different to when you have seen exponent being having the -1. This is different to that exponent. This is not the exponent -1. And this is where math can get a little bit confusing because sometimes the notation is used differently. This is not. So you use regular sine theta is equal to x when you know the angle measure, the theta is known, and you're trying to find one of the side length, either opposite side or the hypotenuse length, because you know what the x is, so you know what the ratio is, because sine of any given angle is particular ratio. Whereas if you know the ratio between opposite and the hypotenuse, and to figure out the angle, you would do inverse sine, okay, inverse sine of x, and x being the ratio to get the angle measure in theta. Okay, similarly for cosine, if you know the angle measure and you know the adjacent side or the hypotenuse side, and you're looking for the length of either the other unknown side, then you would use cosine theta, but you would use inverse cosine theta or inverse cosine of x when you do not know the angle. However, you do know the two of the side. In this case, you know the adjacent side length and the hypotenuse side length. Then in that case, you can plug that in here to find the angle measure. And likewise for tangent, you would use it. Tangent of theta, this is when you know the angle measure and you know either the hypotenuse, no, not the hypotenuse, either the opposite or the adjacent, and you're trying to find the either the adjacent or opposite that you do not know. Whereas in this case, this is what you would use. Inverse tangent is what you would use when you know the ratio between the opposite and adjacent. That means you know the side length of both, but you're trying to figure out the angle measure. All right, so in this case, so what do we have here? Inverse trig function. So in this case, sine of 40 degrees is opposite. This is the opposite side over 31. That's the hypotenuse. This is what you would write. So, and you know that 20 over 31 is approximately 0.65. The inverse sine tells me that inverse sine of 0.65 is going to be equal to 40. And 40 that you get is the degree measure. It's the degrees. And so oftentimes I usually like to put sine of 40 degrees here, just to tell me that we're dealing with the input is the degrees here. And in this case, input is the ratio and the output is the degrees. Okay, and then let's just quickly get your phone calculator app. Okay, and this is where you are going to find all the trig functions here. So instead of looking up the trig table, you can just simply enter using here. So if you know sine of 30 degrees, try pressing sine 30 degrees. And different calculators going to do it differently. You might have to put 30 sine, 30 and then enter sine, or sometimes sine and then 30, and it will display it for you. Okay, so in my phone, my iPhone, it's sine 30 degrees will give me 0.5. Cosine of or tangent of 45 degrees should be giving me 1, and so on. Okay, and then to do the inverse, you need to press this second key, and that should pull up the inverse sign and sine with a -1 sign right at the top. Okay, so that's what we covered today. Please enter in the table of content today's date, which is November 12th, and we did the application of trig ratios and use trig ratios to find angle. And I am going to warn you that the homework is a little bit tricky, so I would suggest many of you should be attending the study hall this afternoon because you might have hard time doing it on your own. Okay, that's it for today, and thank you for listening, and have a great day.